This is an online lecture from the MPH programme at the University of Hertfordshire. This is the third of our public health research series entitled The Scientific Method and the Dissemination of Evidence. In today's session, we're going to be looking at what really defines science. What is it that makes science science and not something else? So after the session, you'll be able to explain the scientific method in respect of the null hypothesis, alternative hypothesis, and have an understanding of the concept of hypothesis testing. You're going to understand the need for and process of citation in academic writing. We're going to summarise the main methods of disseminating information in today's research environment. We're going to cover a range of journal article types, and we're also going to look at the standard scientific form of writing, what we sometimes refer to. When I was developing this session, I thought long and hard about how we actually define science, and who better to turn to than a stage magician. James Randi is a US stage magician and someone who refers to himself as a scientific skeptic. This is how he defines science. Science is best defined as a careful, disciplined, logical search for knowledge about any and all aspects of the universe, obtained by examination of the best available evidence, and always subject to correction and improvement upon discovery of better evidence. What's left is magic, and it doesn't work. So let's come up with an operational model of the scientific method. I've broken this down here into 4 boxes. You observe, you invent, you predict, and then you test. Taking observation first, I look around at the world, and based on the phenomena that I can perceive, I connect things, and from that I invent what we would call my hypothesis. So let's take an example from public health and from medicine. If I look around and I look at people who smoke, I observe that a lot of people who have chronic obstructive pulmonary disease, COPD, a lot of them have smoked. So my hypothesis is that smoking and COPD are linked. Now, the most important part of the scientific method is the testing. Using my hypothesis, I'm going to predict that the more you smoke, the higher the chances are of you getting COPD. That's my prediction. Now, putting ethical considerations aside, and of course we did those in the last session, if I was going to test this hypothesis, I could give lots of people lots of cigarettes and observe them over time to see if they develop COPD. Of course, some of them may contract COPD and it may have nothing to do with the cigarettes. So how do I solve this? Well, I could separate my population into 2 groups, and I could give half of them lots of cigarettes and the other half no cigarettes, and we could see if there was a difference in the prevalence of COPD at the end of the study. Now, of course, this is totally unethical, and this is, of course, something that we could never do. Not only is it totally unethical, but it would take an incredible length of time for us to sit and observe, during which presumably people would be coming to harm while waiting for the results. But this testing phase, at least in an ethical manner, is what makes science science. Just as a quick addendum, and so that I don't get struck off, how would we look at this association between COPD and smoking? We could use a retrospective cohort approach, which we'll come on to later, or we could use a case-control study. And again, we'll be covering these approaches afterwards. So you will have noticed that we use the word hypothesis a lot, and hypotheses are really, really important in science. Now, as scientists, we're cautious people, and so we have an approach with a very long name, but which is really important to the scientific method. We call it the hypothetico-deductive model. This model uses 2 different hypotheses, which are the opposites of each other. The first of these is what we call the null hypothesis. The null hypothesis assumes that there is no relationship between the 2 variables which we're interested in. In this case, taking our COPD example, the null hypothesis is that there is no association between smoking and COPD. Like I said, we're cautious people as scientists, and therefore this null hypothesis is the hypothesis that stands, and our efforts must be that we reject, or what we term falsify, this hypothesis. At this stage, I'm going to turn to the work of Sir Richard Doll, and a really, really important paper that was published in 1950 that for the first time identified the relationship between smoking and lung cancer. In this paper, which is referenced below and which was published in the British Medical Journal, there were two hypotheses. The null hypothesis was that smoking is not associated with an increased risk of lung cancer, and the alternative hypothesis, which is the positive one, said there was an association between smoking and the risk of lung cancer. The paper outlined below therefore rejects the null hypothesis and finds that there is a positive association between the two. So there you have it, in 2 slides, the basis of science. In this next section, we're going to look at some of the more practical issues that will affect you when you're reading and producing your own scientific research. We're going to look at referencing, and then we're going to look at some of the ways that you disseminate your evidence. Now, most of you will already be familiar with the process of referencing scientific literature. Referencing is really, really important because it allows researchers who read your work to follow what you've done and identify the sources that you've used. There are 2 dominant approaches to referencing. The first of these is the Harvard approach, which will give you the name of the author and the year in parentheses following the statement. And the second of these is the Vancouver method, which uses numerals. In the medical literature, the Vancouver method is more common. However, when it comes to social sciences, the Harvard method is still preferred. Each journal will have its own approach to doing this. If you're preparing a manuscript for a journal, it's really important that you look at the author guidelines and the house style which the editor has laid out. You can see on this slide that we've taken one approach which gives us the authors, the title, followed by the journal, the year, and then the individual volume issue page number. But sometimes these are provided in a slightly different order. Sometimes the year, for example, will come before the title of the actual manuscript. You just need to make sure that you're consistent, and there's lots of software that can help you do that. Journal articles may be the quality standard for citing evidence, but of course there are lots of other sources of evidence too. There are conference proceedings, there are books, patents, reports, even down to Wikipedia and BBC News articles. All of these can be cited, but only some of them should. There's a reference at the bottom of this slide that looks at the use of Wikipedia citations in the peer-reviewed health science literature, and you'll see some of that in the C block of this session. I do recommend a read. It is quite frightening what people are willing to cite. Given the quantity of information that is now easily accessible to us, there have to be questions about how you go about sourcing it and how you go about appraising it. Whereas just 20 years ago, physical libraries were the main place that you went to find out about the evidence, today almost everything is available online. Medline, available through the PubMed website, is one of the online indices through which you can begin to search for evidence. Of course, there is also Google Scholar, which looks more specifically at the evidence, as well as the wider Google search that is often, in reality, the starting point for most researchers looking into what's going on. We'll be undertaking a workshop for using web search, both the structured indices such as Medline and PsycInfo, and also how you go about using Google Scholar and so on in upcoming workshops. But a really important thing to consider at every single stage is how much can I trust this piece of evidence? An important point which is sometimes ignored or at least forgotten is that even within so-called learned journals or the peer-reviewed press, there are some articles which are of course peer-reviewed, but there are also some which aren't. On this slide, you can see that we have separated out the different types of article which are published in journals like Nature or The Lancet. There are broadly 4 different sorts of article that are published. There's research, which can be primary or secondary, primary being where there are new data which have been collected and new observations. Secondary research, which we will cover later on in this series, which is the analysis of existing data. There is theory, which is where established principles are challenged or questioned or new ideas presented which might be possible to test in the future. And then there's also the review, which brings together lots of established and published research and sometimes will throw up new ideas or new findings. But there's a 4th group, which we call opinion, which can be separated out into what might be editorials and what might be comments, which aren't peer-reviewed, which often accompany research, sometimes in that particular publication, which, not being peer-reviewed, should not be considered as necessarily the same level of evidence that the research articles are. Sometimes when you're searching for material and you get linked to an editorial or to a comment, it's important for you to go back to the original piece of research upon which that editorial or comment has been based. So let's talk a little bit now about the standard structure that most scientific literature is presented in. There are 4 major parts: the introduction, the methods, the results, and the discussion. These are often preceded by an abstract, which will give a general overview of the piece of work in about 250 words. This structure of introduction, methods, results, and discussion is sometimes referred to as the IMRAD structure. It's really important that you understand which part of your research should go into which section. One of the most frustrating parts of being a peer reviewer is when you can see that there are certain parts of the presented manuscript which are simply in the wrong section. And this is an error that can be really, really simply avoided with a bit of understanding. The first part is the introduction. And in biomedical journals, at least, the introduction is normally quite short. It's often actually limited to maybe 2 or 3 paragraphs. It will cover the background and the reason that your paper is important. In a lot of the social science literature, the introduction, or sometimes referred to as the background, can actually be quite long. The second section is the methods. And this outlines everything that you would need to be able to reproduce the scientific experiment yourself. It should at the very least specify the study population, the outcome of interest, or possibly outcomes, how you collected the data, and really importantly, how you analyse the data. The third section is the results. These are often in table or chart format with an accompanying section of prose which refers to the table or to the chart or figure in question. It simply gives you the facts. It does not discuss them. It is just the facts. The fourth section is the discussion. And this is the bit that often gives people the biggest challenge in them understanding what should go in the results and what should go in the discussion. The discussion is how you contextualise the results, and it can be broken down into a series of subsections. The first paragraph of the discussion should outline the principal findings. And that means that when you go to any paper, you should be able to look immediately at the first paragraph of the discussion and see what it is the authors are proposing. The discussion will then interpret the results in light of the context, and often in the context of the background and introduction and the references that you've introduced earlier in the manuscript. The evaluation should also be included, and that will cover the strengths and weaknesses. And a really important part of real research is identifying what the implications of your research are, the so-called so what. The final part of the discussion might try to identify what the gaps now are in the literature and identify any interesting research questions for the future. Often articles conclude with, and more research is needed in this area, and that's something which can upset journal editors and is something best avoided. With the structure understood, there are also further important conventions which must be observed when writing in a scientific style. I have picked out precision, concision, and clarity as being among the most important. Academics are often the ultimate pedants. When trying to get your paper published, you just have to accept the pedantry and work with it as best you can. One particular challenge and convention that I still find really difficult is remembering what tense to report your findings in. In fact, the tense of your writing will change through the actual manuscript. Because the scientific literature which has been presented and accepted and published is considered as true, we always refer to that literature in the present tense. And that means that your introduction will normally be in the present tense. Of course, there is one exception to this, and that is where you're actually naming scientists. So if I use a name in my introduction and say, Taylor found that X was connected to Y, that would be placed in the past tense because I was using a name, even though it should be in the present tense because it's referring to established research. Confusingly, because your literature, your evidence that you're presenting in this particular article has not necessarily been accepted, you generally refer to your own work in this particular piece of research in the past tense. And this means that the methods and results section are normally in the past tense. And of course, finally, the discussion, because it's contextualized with existing research, you often present your discussion in the present tense. For this reason, it's really important that at the end of writing a piece of scientific literature, that you go back and you make sure that everything is in the correct tense. And often, particularly with literature reviews, which you may have written over a course of several weeks and on multiple different occasions, you may well have slipped from one tense to the other. And it's really important that you make sure that that is consistent throughout your piece of writing. So there you have it. We've covered the scientific method and what the difference is between the null hypothesis and the alternative hypothesis. We've looked at citation, and we've looked at different article types and the scientific writing style. Now, for most of you, I suspect none of this is new, but hopefully we've given it a little bit more of a theoretical backbone. And it's really, really important that some of those subconscious things that you've been doing in the past come to the fore, and you really think about how you're doing things and how you're reporting your science.